What a smooth start to the lesson that was. That was the sound of me kicking over some glass bowls that we're going to need later. Hello everybody, hi, Lara here from Theatre of Science. I am so excited. There's a lot of new people here today. Volcanoes, what a brilliant idea that was. Thank you very much for whoever suggested that last week. A little note, for one of the experiments, you are going to need eye protection. It could be goggles, glasses, anything you like. We're going to blow into a gloopy liquid and there's quite a lot of splashback. Other thing is, we are going to be using fire in about 3 minutes. So if you're wanting your kids to watch this and if you to go off and work, we're going to be putting paper over a candle. It's probably better that you stay and supervise just for that bit. Quick quiz, first of all. Think about what you know, what you don't know. By the end of the lesson, you should know it all. What is a volcano? There's 4 main bits that come off a volcano. There's these little purple dots. I'm not going to tell you what anything is yet. There's this foamy stuff. Got my beautiful cloud up there, look at that. There's these purple dots, there's this stuff, and there's this stuff rolling down the sides of the volcano. I want you to tell me, what are they? Is this fire? Is it rock? Is this smoke? Is it ash? What is it? And which bit is the most dangerous to humans? Which one of these 4 bits is the most dangerous to humans? It might surprise you. And if you want to do some really deep thinking, which one of those bits do we think might have killed the dinosaurs? So have a think, and by the end of the lesson I will give the answers and we will find out what all those different bits are. But before we actually look at volcanoes at all, I want to talk about models. In a minute you're going to make a model of a volcano. I'm going to show you the model of the volcano that everyone on the internet says that you have to do. But what actually is a model? So scientists use the word model in a slightly different way to how normal people do. A scientific model is something that helps you understand something better. So if something's very complicated, you can simplify it by using a model. For example, my kid's been playing with my toy globe is over here. So this is a model of the Earth, okay? It's a good model because it's a ball shape and the Earth is a ball shape. But if you wanted to understand how the Earth worked, well, it's got the countries on it, hasn't it? So yeah, it might help you. If you wanted to know where all the countries are, that would be quite a good model. This is a globe. Is it a better model of the Earth? Well, it's got all the countries on it. It is a ball shape, but it also spins round and round, and it's on a tilt. So if you wanted to understand how the Earth was moving, this would probably be a better model to look at. But models aren't always better just because they're more complicated. So for example, I live in York, we get a lot of visitors in York, a lot of tourists. If you were stood at the cake shop and you wanted to get to the Minster and you said, oh excuse me, local from York, can you tell me how to get there? If I gave you this map, then you'd probably be a bit freaked out. You'd be like, what is that? There's so much detail on there. I can't. House of Trembling Madness sounds delicious, but it's not what I asked you about. You would probably be much happier if I gave you something like that. It's backwards, sorry, but you know what I mean. The cake shop, the Minster. So it helps you understand how to get to the Minster, doesn't it? A lot better than that. So models, scientific models, complicated isn't always better. Let's get you to make a model. Okay, I want you to do your model first and then I'm going to show you the fancy internet version. You're going to make a model, so this is the bit where you need your candle. I'm using a beeswax candle. That's better, isn't it? There you go. Let's light the candle then, and all you're going to do is get an A4 piece of paper and roll it up into like a long toilet tube shape in a minute. So, it's totally simple first of all, but actually, yeah, it has the potential to be quite dangerous. I got a surprising result when I did this. All I want you to do first of all, if you've got a candle lit, is hold your hand maybe like a metre above the candle. Start really high. Hold your hand about a metre above the candle and see what you feel. Okay, I've gone quite high. I've gone really quite high, like at least 2 normal rulers. You probably can't feel very much. Why is that? Well, it's because this heat from this candle is what we call dissipating into the air. So the air particles here are getting warm, they're passing on the heat energy to all these air particles, so by the time the heat energy gets to your hand, it's very, very spread out. Now what I'd like you to do is just get an A4 piece of paper, like I say, probably want the adult to do this, or the grown-up in the room, so that you can concentrate on where your hand is. And just hold it above the candle, obviously not so much that it's not so close that the paper sets on fire, but hold it above the candle and then put your hand in the same place again and see what you feel. And you should find it's really hot. It's really surprisingly hot. So like I say, be careful. Do it with 2 people so you don't get distracted and burn yourself. Why is it hot? Well, it's because you've made a little tunnel here, haven't you? So instead of heat energy being wasted all around here, you're forcing hot air all the way up through this tube and it's coming out at the top. Now, I think that's quite a good model of a volcano. Myself. Come over here and I'll show you the internet version. You might want to do it at home if you've got the stuff. It is fun to do. I thought people might not have the stuff, so I'm just going to do it for you. You just watch this one. All it is you get a bottle, you put some vinegar in it, and what the internet says is that you just get bicarbonate of soda and you pour that into the vinegar. Bicarbonate of soda sounds very complicated. Carbonate is scientists' way of saying that it's got 1 carbon particle in it for every 3 oxygen particles. And what the vinegar does is it grabs one of the oxygen particles away from the bicarbonate of soda. So basically it's a chemical reaction. You put vinegar and bicarbonate of soda together, all the particles pop off, mix together, whiz around, and what you're left with is a totally new particle which is going to come out of the bottle. Now, the internet says that I have to add some, here we are, red food colouring, because red stuff comes out of volcanoes. And the internet said, that was disgusting, wasn't it? That was a lump of food colouring. The internet says I have to add some washing up liquid, just for awesomeness, to make it a bit more foamy. So let's do that. I want you to be thinking about what's the difference between this model and your model, and then stick a bit of paper over the top of it, you know, so it looks a bit more like a volcano. Right, off we go. Are you ready? I'm using quite a lot more than I used in practice because I didn't want to waste it in practice, so this, I don't quite know how good this is going to be. Let's go. Give it a little shake and shake. Izzy did this with whoa, there you go. Izzy, you distracted me with your comment about doing it with Google. There. Alright, so, well, objectively, that is awesome, isn't it? Look at that. Wow, that is very cool. But is it a better volcano model than the model that you just did with your paper and your candle? Oh, look. Oh, okay, this is quite interesting, actually. Look, we've got bubbles of gas, carbon dioxide gas, escaping from the lava. Ugh, do you know, I might be changing my mind about this model. I have always thought this model is a bit silly, but that's pretty awesome. Okay, but to decide which model is better, you're kind of satisfying, so someone, yeah, it is very satisfying. To decide whether whose model is better, the internet's model or our model that I made up, we need to learn about volcanoes, don't we? Let's learn about volcanoes. Alright, let's start with this bit. What is this bit? What is this bit? Why is it red? We've all seen a volcano that looks like this, brown, bit of red on top. Why is that red? Why is it red? Come on. Say it out loud, even if you're not commenting. Use your brain. Why is that bit red? It's so cool. Nancy, it's the opposite of that. I'm going to make the lava blue, I think. People, come on, focus, get with the program. Why is this stuff red here? My paper got on fire, Ruth. You focus on you. You focus on you. I'm waiting for an answer. Come on. What is this stuff? And why is it hot? Is it because it is super hot? Joe Allen. Thank you very much. Yes, it is very hot. And what is it? It's lava. Thank you. It is actually melted rock. So already, internet volcano, not hot, is it? So maybe not as good a model as your model. If you like Julia Donaldson, love Julia Donaldson. If you've read The Snail and the Whale, you might remember this. Mountains of fire. Bless you, Julia Donaldson. I love you, but this is absolute nonsense. There is no fire coming out of volcanoes. It's melted rock. Exactly, it is. So why is melted rock coming out the top of the earth? Well, it all starts about 4.6 billion years ago when the Earth forms, and the whole Earth is basically just one big melted, very, very hot rock. And then the outside of the Earth cools. About a million years later, it gets this nice crust on it, but the inside of the Earth stays very, very, very hot. And there's a lot of gases inside the Earth. Rocks are continuously melting, and they're releasing gases. If you've ever seen steam coming out the top of a kettle, that's just water that's turned into a gas. It's exactly the same thing in a volcano. If you did our hot air balloons lesson, you know that when stuff gets really hot, then the particles get more energy and move apart, and the thing becomes less dense. And what does stuff do when it becomes less dense? It rises up. So this very, very hot rock, which has got gas in it, the gas gets less dense, and the hot rock itself is less dense than the cold rock. So it all rises up, and about 2.2 billion years ago, the first spurt of melted rock came out of the Earth, and they've been going to this day. Have you heard of lava? Have you heard of magma? Do you know what the difference is? Well, the difference is melted rock when it's inside the Earth is called magma. This is a magma chamber, so the melted rock goes up a little bit and then gathers in what we call magma chambers. And then as soon as it's on the outside of the volcano, the melted rock is called lava. So this is lava dribbling down the volcano, and this is magma waiting to come out. And the difference in thickness of the magma and the difference of how much air it's got trapped in it, that affects what kind of volcano you get, which leads us to our next experiment. Goggles on. Chocks away. Come down here with me. Don't need this candle anymore. What you do need is your 3 cups. I'm using massive bowls so that you can see better. And all you're going to do is, you're going to fill one bowl with water, you're going to fill another bowl with water and flour mixed together to make a sort of thick-ish paste, and the third one is going to be a really, really thick paste. So we've just got water, really thick paste, and then one that's in the middle. I've just remembered that a couple of lessons ago, I kept pretending that I'd forgotten stuff, and my evil twin sister kept appearing. It's alright, my evil twin sister has gone home. I have genuinely forgotten the water. I'm going to go and get it. You start mixing up your stuff. Never happens on Blue Peter, does it? Oh, I've forgotten the sellotape. Sorry, everybody. Right, so I'm going to do this with you because I'm assuming that you might be doing it at home. So I'll do it in real time. So this is the thin-ish one. I'm doing it wrong, aren't I? If you're good at baking, you know that you're supposed to put the flour in first and then add the liquid so that you don't get lumps. What are you doing? Okay, so what I'm doing is I'm mixing flour and water in a bowl so they get a nice thick smooshy mess. It's like Play-Doh really, very, very wet Play-Doh. Okay, so you've got 3 bowls. One bowl is just going to have water in it. One bowl you're putting in some flour, or maybe you're doing it with mashed potato. Because I did an experiment at the weekend because I was worried that no one would have flour. And the results of the experiment were that mashed potato worked really well. But you definitely do need eye protection for this one, folks. Because actually my son, bless him, he's only 4. He got some mashed potato in his eye. He was not happy about it. So this is my thick one. You definitely don't want it any thicker than that. You want it to be able to drop off the spoon. What we're going to do is we're going to make a little straw out of a piece of paper and we're going to stick it in and blow it. Yeah, if you've got mashed potato, make some watery mashed potato that you can blow in. All you're doing is you've got 3 mugs. One's got water in it, one's got very thick, floury, watery liquid in, and the other one's got a slightly thinner one in. So, this is just the water. So this is, in scientific terms, we say it's not very viscous, it's not very thick, it flows very, very easily. Lava that flows very, very easily, it's very thin, it just comes out of the volcano and then it just flows away, and that forms something called a shield volcano, very flat. The biggest active volcano on the globe at the moment is in Hawaii. It takes up half of Hawaii, and there's another right next to it, and they're both shield volcanoes. There's some gorgeous videos online of it all going into the sea and then flowing over. Right, let's have a look at this then. So what you're going to do now is just get a piece of A4 paper, roll it up into a straw. Doesn't matter if it's thicker than a normal straw. There we go. what you're going to do is just, you've only got green and blue food colouring. Well, that'd be alright. It's not hot, is it? It doesn't matter what colour that model is. That's just my problem with that model. Put your little straw into your water and give a very, very, very gentle blow, please. Okay? Super gentle. So what did you observe? Good scientific word. What did you see? You probably saw lots of bubbles. Those bubbles were gas escaping, and it escaped quite easily, didn't it? That was a really gentle blow, and a bubble just came out straight away, pop, and went into the air. This is what happens with volcanoes where their lava is very, very thin. The air gets out quite easily. Let's move on. Let's do this slightly thicker lava. Ready? Deep breath. Whoa. So you can already see there's quite a bit more splashback there, isn't there? But the bubbles still came out fairly easily. Now, get your thickest one. Very, very thick lava forms volcanoes that are shaped like cones, because very thick lava, very viscous in scientific terms, it can't flow very far. So it comes up the top of a volcano and then it just sort of stays there, and this is why you get these cone volcanoes. People who don't study volcanoes for a living, like me, would call them the proper ones. They're actually called stratovolcanoes. Lava that is very thick is much more dangerous, it's much more explosive, because air gets trapped in it and kind of builds up. So let's have a look. Just realised I had done that awful classic thing of having my eye protection on top of my head. Get your eye protection on, people. So this is the thick one. I'm just going to do a really gentle blow. So nothing happened. Did you see that? The water, the thin, not very viscous liquid, let the gas escape really easily. Thicker lava doesn't let the gas escape easily. So I'm going to, I loathe to say it, but you are going to have to blow it a little bit harder, okay? Oh, it's the sound that's the best bit of that. Give the little mug a wobble so it all settles, and try that again and listen to that lovely sound of a really big bubble of gas that's been building up for a while escaping. Ah, yes! Ah, love it. You can have fun with that later. You're not going to listen to a word I say now, are you? You're just going to be blowing into sloppy Play-Doh. I'm glad that I could make that happen for you. Stratovolcanoes, thick lava, much more explosive. But lava, actually, nothing like the most dangerous part of the volcano. Nothing like it. If you watch horror films, scary films about volcanoes, it'll always highlight the lava like chasing people. But lava moves really slowly. Very, very few people die because of lava, because you can just move out of the way. Far more dangerous is this stuff here. Now, what is this? Again, Julia Donaldson spreading these lies. That is not smoke. There is nothing burning inside a volcano. It looks like smoke because water vapour, you know, like steam from your kettle, and carbon dioxide and all different gases are pushing a load of stuff out of the top of the volcano. But it's not smoke. It's actually teeny tiny little particles of broken up bits of rock and lava, like 2 millimetres wide. Now, if you have ever broken a glass on a hard floor and watched the adults in the room freaking out, you have probably noticed they don't freak out about the really massive bits. They might, even if you're sensible, let you tidy those bits up yourself. They freak out about the teeny tiny little bits. They're like, no, don't come anywhere in here for the next 72 hours because there might be tiny little bits. And that is basically, if you imagine a cloud of those tiny little glass shards, that's what that is. So imagine breathing that in and that getting into your lungs. It can really, really damage your lungs. And in fact, if it damages your lungs to the point where your lungs have water on them, then you've ended up with lots of tiny little bits of mud and water in your lungs, and it can turn your lungs into cement. I know, not cool. That's why older people in the room, you might remember the volcano in Iceland that happened in 2010. That's why when that happened, like every airport in Europe was shut for a week. It wasn't because aeroplanes didn't want to drive through the smoke. It was because these little glass shards can get into aeroplane engines and stop the engines, and the plane just falls out of the sky. So they are dangerous, but the volcanic ash is not the most dangerous bit of the volcano. No, nothing like the bit of the volcano that if you're a volcanologist, a person that studies volcanoes and goes onto volcanoes for a living, the bit that terrifies you the most, the words you don't want to hear, are pyroclastic flow. Pyroclastic flow, which is lots of solid. So obviously, when a volcano erupts, loads of stuff shoots into the sky, but it doesn't carry on going into the sky forever. A lot of it falls back down again and falls down the volcano. It's really big stuff, and it is solid, but it's called pyroclastic flow because it really flows. In fact, well, do something for me. Hopefully you've got your old manky straw, haven't you? Unravel your straw, or get a scrap piece of paper, squidge it into a ball, and just roll it along a surface. Roll it along a flat surface like a table. If you've got two surfaces, roll it along a carpet as well. You will notice that it stops. Okay? If you roll a ball along a floor or a carpet, it stops. If you roll it along the carpet, you probably notice that it stops sooner than it stops on a smooth surface. Now, Newton came up with this idea. We met him in our rainbows lesson. Everything stops eventually if it's pushed on by a force called friction. So anything that's touching other things as they move along is going to feel a pushing force called friction. So it sounds weird, but your ball stopped because the table was pushing back, and the carpet, it's rough, it has even more friction, so the carpet pushes back with more force, so the ball stops. Pyroclastic flows, they don't seem to obey the laws of friction. Like, scientists couldn't work it out. So your house is probably about 10 metres high. Pyroclastic flows move 200 metres in 1 second. Imagine that, something travelling 20 of your houses high in 1 second. And uphill, it didn't matter. Rough surfaces, didn't matter. It was just... and this is because scientists took a long time to work this out. It's only last year, and actually it was through computer modelling. So most models that scientists do now are on the computer. They put some data in and they found out that this pyroclastic flow is like generating its own air cushion. So air and gases that are trapped in the pyroclastic flow get pushed to the bottom, and yeah, it's like riding on a bed of air. If you've ever been to a cinema or some sort of arcade and you've seen an air hockey table, it's very, very similar. So if you've played air hockey, it's amazing. These little discs just seem to fly across the table really, really fast and don't obey the laws of physics. It's just the same thing. It's like an air hockey table, except the hockey pucks can be the size of cannonballs or like the size of your house. It's easy, especially when you live in the UK where there are no volcanoes, to think, oh, volcanoes are awesome. They're also incredibly dangerous. Oh, I know what I wanted to show you. Sorry, I'm being thrown because I only just found this out and I thought it was cool. In our rainbows lesson, I showed you something called a spectroscope. It's just cardboard and a tiny little CD, and can you see in there that something about the design of the spectroscope? I think if you go to my rainbows lesson on YouTube, the link to build this is there. What it shows you is that light is made up of all the colours of the rainbow. Now, it is an incredibly dangerous job for scientists, volcanologists, to go onto the top of volcanoes and take samples of gas and find out what gas is coming out of the volcano. So what physicists have done is they've built pieces of equipment. It's basically a massive one of these, and you point it at the volcano and the gases give off a slightly different rainbow to normal air. So you can look at the rainbow and that tells you what kind of gases are on the volcano. So maybe you don't need to go up as often. How cool is that? So I know I was a bit paranoid that maybe volcanoes are geography, that this was a geography lesson, but it's definitely a physics lesson as well. All right, it's time for story time. Now, our story this week is a little bit different. We usually look at some sort of massively famous scientist who's made loads of incredible discoveries. Our scientist this week isn't like that. Come over here with me into my Storytime box. Regulars are very used to my Storytime box. Here we are. Give me some light. Yeah, most scientists do not get famous. This is a story of someone who, by just quietly studying volcanoes her whole life, has probably helped to save thousands of strangers' lives, which he couldn't say about Newton. could you? And she just got famous by accident when she had to save the life of her friend. Marta Calvache was born in Colombia in a town called Pasto, which sits at the foot of a volcano called Galeras. Now, Marta's friends described her as energetic, clever and tough, but Galeras was very quiet while Marta was growing up. So to be honest, she didn't even really ever think about the fact that there was a volcano there. She went to university to study rocks. And then a town nearby where she was studying was destroyed by an eruption. It was a real big disaster, and it wouldn't have happened, it's absolutely true, if the locals had been warned about the volcano. And Marta was really shocked to discover that actually very few people had studied Colombian volcanoes. So she decided there and then to devote her entire life to volcanology, studying volcanoes. Now, while she studied volcanoes, she did a lot of work with a man called Stanley Williams. Eventually, she went to America with him and she worked on him with a higher degree, what's called a PhD, to become a doctor. Choosing a volcano to study, it wasn't hard. The one that she'd grown up next to her whole life. She chose Galeras, and she discovered amazing new things about the Galeras volcano. She discovered a new type of pyroclastic flow. She found some dark yellow rocks, and she worked out that they were really old decay rocks which get spewed out when the volcano first erupts for the first time in a long time. It's sort of like it's clearing its throat. She walked every inch of Galeras. She knew it incredibly well. She knew it so well that scientists actually named a bit of the volcano after her. Now, in 1988, she visited Galeras. Now, she had done a lot of times before, and she was very surprised to find jets of gas shooting out of the volcano. And every time she went back, the gas chutes had got bigger and they'd got hotter. So she did all this measuring, and she found out that Galeras may have been asleep for 40 years. But now it was awake again. Still, it hadn't erupted for 6 months when her good friend Stanley Williams said that he was going to go to the top of the volcano and study it. He was a volcano expert. Don't forget, he's in charge of whether she gets her PhD or not on volcanoes. There hadn't been any gas coming off the volcano for a bit, so they thought, okay, not much is happening. It turns out actually that the gas being given off was quite acidic, like the vinegar that we used earlier, and it was melting a lot of the rocks closed, so the gas couldn't escape. So actually, Galeras at the time was like a pressure cooker. The day that Stanley went up to the top of the volcano, 2 other scientists arrived to study the volcano, and they were wearing protective gear. They were wearing hard hats and they were wearing fireproof clothes, and Stanley laughed at them. I will tell you that those 2 scientists came off the volcano totally unhurt by what was to happen next. When the volcano erupted, a lot of scientists were working on the lower slopes, and one group said that they heard a rumble above them and thought it was thunder, so they weren't that worried. And then the rumble just kept going and kept going. And then ash, remember what I said about volcanic ash? Volcanic ash started to drift down from the clouds, and that group decided to get in their van and very, very quickly get off the volcano. Marta's group was actually the closest to the top of the volcano, and she knew immediately that it wasn't thunder and that a volcano has erupted. So she told her group that they should go back down to the town and that she would go up on her own to find Stanley. But another woman, Patty, who was also a volcanologist, she said that she'd go with her. So the 2 of them and 2 soldiers got in their jeep and drove up the volcano. When they got to the top of the volcano, white rocks all over the ground, Patty spat on one and it hissed at her. And they told afterwards that the volcano was giving off an eerie sound like the howl of a strong wind. The swirling clouds parted, and Marta and Patty could see a column of thin ash coming up from the crater. So they stared through the fog, incredibly difficult conditions to see anything, and then they heard Stanley calling for help. Now the rescue teams hadn't arrived, but Patty said later, just felt it was my destiny to help. The 2 soldiers, the 2 Colombian soldiers who had come with them, were too scared to go all the way into the volcano. So these 2 and 2 of the volcanologists who'd run up from town in their cars when they heard the eruption, they put Stanley on a stretcher and carried him to safety. He was incredibly cold and not making any sense when they found him. So they carried him half an hour through a volcano and got him to safety. For years, Stanley was absolutely sure and told the story that Marta and Patty had been with him in the helicopter, but actually they had stood on the ridge at the top of the volcano and watched as the helicopter carried Stanley to safety to the town, 5,000 feet below. Marta later wrote a scientific paper about how to behave during a crisis on a volcano, and she said to ask yourself, is what I'm doing for the good of the people, and are my words and actions respectful and fair? And she advised that anyone working a volcano should work as a team, and that scientists should be chosen who have great leadership skills. So if you're not amazing at maths, or you're thinking, oh, I could never discover amazing things like Newton did, just remember it takes a lot of different skills to be a scientist. And Marta actually still works on Galeris, monitoring it and protecting the town below. So I hope you enjoyed that story time. Oh, sorry. Oh, it's time to answer our quiz questions. Okay, so some of them, hopefully, you have picked up the answers as we've gone along. What is this? It's not smoke. It's ash, tiny little glass shards. What is this? It is very, very hot rock, which is called lava, but this is called magma. This is pyroclastic flow, and this up here is gas. We'll call it carbon dioxide gas. Now, which one is the most dangerous to humans? Say it out loud, or describe it out loud. It's quite a hard word, isn't it? The pyroclastic flow is by far the most dangerous. Which one do we think might have killed the dinosaurs? It was actually this stuff that we haven't really talked about. Volcanoes give off carbon dioxide because rocks have got carbon in them, and when the rocks melt they release carbon dioxide gas, which you might have heard of if you've done any learning about global warming, about how the earth is getting hotter because of carbon dioxide in the atmosphere. Possibly what happened to the dinosaurs is that there was such a big volcanic eruption that the air filled with carbon dioxide, and that changed the temperature of the earth. We think that's what killed them. Little note on the carbon dioxide. You sometimes hear people saying that volcanoes are really bad for the atmosphere and there's no point in humans not driving cars because one volcano would counteract all that. It's not true. Volcanoes are producing, I think it's like 0.2% of what humans are producing. And also volcanoes have stayed the same for like billions of years. So they're not changing the climate. It's humans that have started giving off more CO2. Oh yeah, the most important bit. Which is the best model? Right, let's have a look at this one then. It's a bit sad now, isn't it? Which one is the best model then? Have you learned enough to be able to tell me which one's the best model? This one or your candle one? Now I have made some notes here, but you can use the comments box. Please tell me which one do you think is better, candle or this one? I think that volcanoes are hot and the internet model is not hot. It gives off no heat, and your model gave off quite a lot of heat, so I'm going to call that 1-0 to our model. What else? Why is this a bit like a volcano? Why is this like a volcano, and what's the difference? Well, the internet one is red and volcanoes aren't red, but I think that's a cheat because it's not hot, is it? I don't think it really helps you understand a volcano, like people were saying. You could just do it blue, couldn't you? Volcanoes aren't a chemical reaction. It's not particles rearranging. It's just rock that is solid, melting, and then coming out. So I think that makes your model better, because on your model, the candle was heating up the air particles, and the air particles were getting hotter and coming out of your chute, but it was still air, whereas this one, the stuff that goes into the volcano is not the stuff that comes out. Anything else? Can you think of why this model is better, or why this model is better? This one has something that is becoming less dense. The air becomes less dense and so rises, just the same as rock becomes less dense and rises. So, you know, I could go on for a long time. This one gives off carbon dioxide, real good thinkers might be saying, but actually candles give off carbon dioxide as well. So that's just another one all. Basically, I think that the model that you've just done is a lot better than this volcano model, even though this volcano model is awesome, and that next time you get told at your primary school, can you bring in a model of a volcano, you should have the guts to just do that. There you go, teacher, what are you going to say? I'm going to give you a few very cool facts about volcanoes before we finish. I think I'm going to do a lesson on earthquakes, so I don't want to get too much into how the earth moves, but it's quite a cool fact that the entire ocean floor is basically lava, and that the ocean floor is pulling apart and volcanoes are spewing up and like creating more ocean floor. So the oceans are actually growing. In fact, I made a little map for you. Paris, which is over here, and New York, which is over here, are actually getting further apart every year by about the same distance that your toenails and fingernails are growing. The largest volcano in the solar system is Olympus Mons, which is on Mars, but the only other place with active volcanoes that we know is Io, which is Jupiter's moon. I thought you planet fans would like that one. Oh yeah, and I always like to mention science that we don't know too much about, so that you can go away and study it and get a job doing it. You hear about volcanoes being overdue. That is absolutely not true. It's not the case that if a volcano hasn't gone off for 500 years, then it must be overdue and it must be about to blow. It seems to be fairly random. A volcano could go off like after 5 years, or it could go off after 100 years. So we don't know. So this phrase overdue is not quite right. It doesn't seem to be that a volcano uses up all its stuff and then it has to like generate more stuff. But we don't quite understand that. So that might be one of the cool things that you could become a scientist and discover. Right, that is the end of all the information that I'm going to give you about volcanoes. Cookbook, which I'm not going to do like creative person modesty about. I'm pretty proud of actually. It's just my favourite recipes with a little bit of science on each. Feels like I've really connected to a lot of really like sparky kids, which I would like to carry on seeing. So what I'd like to do is do some sort of after school club. If you want to go on my Patreon and just read more about it, that would be very much appreciated. Alright folks, lots of love to you. Thank you so much for joining me, and I will see you next week. Bye!